Hello dear students of plus 1 medical and non-medical respected teachers. So in this video I am going to discuss very important theorems known as theorem of perpendicular axis and theorem of parallel axis, and these theorems are very useful to find moment of inertia of like ring, disc, rigid bodies. So let us start theorem of perpendicular axis. The question may be asked, state and prove theorem of perpendicular axis. So these theorems are very useful. So understand it both the theorems carefully. First of all, statement of theorem of perpendicular axis. So suppose we have three axes, x-axis, y-axis, z-axis, which are mutually perpendicular to each other, and a plane lamina lying in xy plane, and z-axis is the axis perpendicular to the plane of lamina or xy plane. Then, according to theorem of perpendicular axis, moment of inertia of this plane lamina about a perpendicular axis, that is z-axis, is equal to the sum of the moment of inertia of the lamina about two mutually perpendicular axes, that is x-axis and y-axis, in the plane of the lamina intersecting at a point where the perpendicular axis passes. That is, x-axis, y-axis, z-axis are mutually perpendicular to each other. So again I repeat, theorem of perpendicular axis states that mi of a plane lamina about a perpendicular axis is equal to the sum of the moment of inertia of the lamina about two mutually perpendicular axes lying in the plane of the lamina intersecting at a point where the perpendicular axis passes. In nutshell, mi of this plane lamina about z-axis is equal to sum of moment of inertia of the lamina about x-axis and y-axis. That is, iz is equal to ix plus iy. Simple. Now, to prove it, suppose a particle of mass m having coordinates xy, because lying the plane xy, and let OM is equal to r. So let this point lies at P. Let OP is equal to r. That is, r is the perpendicular distance from z-axis. Then by definition of moment of inertia is equal to mass into distance square. So mi of the small mass m about x-axis will be m into y square. So y is the distance, perpendicular distance from x-axis. So let it be dix. Dix is equal to my square. Therefore, total moment of inertia of the whole lamina about x-axis is given by ix equal to summation my square. Similarly, total moment of inertia of the plane lamina about y-axis is given by iy is equal to summation m x square, because x is the perpendicular distance of this mass m from y-axis. Adding ix plus iy left hand side, summation m common, y square plus x square. Now y square plus x square is equal to r square from right angle triangle. Therefore, ix plus iy is equal to summation m r square, or summation m r square nothing but iz by definition. So therefore, ix plus iy is equal to iz. So sum of the moment of inertia of the plane lamina about two mutually perpendicular axes intersecting at a point where the perpendicular axis passes is equal to the mi of the lamina about the perpendicular axis. So iz is equal to ix plus iy. I think you have understand this theorem of perpendicular axis, and we have to simply use this relation. This application is very important. Then theorem of parallel axis. So theorem of perpendicular axis is used to find moment of inertia of the plane lamina. Theorem of parallel axis is used to find moment of inertia of any rigid body, any body. So according to theorem of parallel axis, moment of inertia of any rigid body about any axis is equal to the sum of the moment of inertia of the rigid body about a parallel axis passing through its center of mass and product of mass of the rigid body and square of the perpendicular distance between the two parallel axes. So it means if IAB, let AB be an axis passing through center of mass of the rigid body which is parallel to given axis XY, about which moment of inertia of rigid body is to be determined. Then IAB, that is moment of inertia of rigid body about AB passing through center of mass. IXY is equal to MI of the rigid body about XY. H is the perpendicular distance between two parallel axes. Capital M is the total mass of the rigid body. Then by theorem of parallel axes, IXY will be equal to IAB plus M into H square. To prove it, very simple again. Suppose a mass M at a distance x from the axis AB or from center of mass. Then Mi of this mass about AB will be mx square, and total moment of inertia of rigid body about AB will be IAB is equal to summation mx square. Simple definition of moment of inertia. Similarly, IXY, that is Mi of rigid body about axis XY, will be equal to summation m total distance h plus x whole square, or summation m h square plus x square plus 2hx. If we open the bracket, it will be h square can be taken outside summation because it is constant. So h square summation m x square, 2h can also be taken out from summation because it is constant, summation mx. Now summation m means total mass. So IXY is equal to h square m plus summation mx square, nothing but IAB, plus summation mx will be 0. Why summation mx is 0? Because body is balanced about center of mass. Either distance positive होंगे तो negative होंगे. So product of m1 x1 plus m2 x2 and so on, algebraic sum of summation mx, that is summation mx, will be 0 because body is balanced about center of mass. This is by definition of center of mass. So therefore IXY is equal to IAB plus mh square, which is required theorem of parallel axis. Both these equations, theorem of perpendicular axis, that is Ix plus Iy is equal to Iz, and theorem of parallel axis, that is Ixy is equal to IAB plus mh square, will be used when we will calculate moment of inertia of ring disc in the next video. So be happy, all the best, good luck.